This is section 1.8 of the Precalculus class, and we're going over the examples here for this section for our class notes. This section is about inverse functions. So in the first and our second example here, we want to be able to find the inverse function. F inverse of x is how this is read for these two functions. So we'll go through that. And then look a little bit about the domain and range of inverse functions. So just a quick reminder, I think we're still in the review part of this course, but if you have an inverse function, what an inverse function right here, f to the -1, it looks like to the -1 power, that is not 1 over f of x or f to the -1 power. It's simply notation to be read as f inverse of x. And what f inverse and f do is they essentially undo each other in a way. In other words, if I stick x into the function f, you get f of x. Now if I take f of x and I stick it back into the function f inverse, out would pop x again. So it undoes x from f of x and pops x back out again. It's the same way with f inverse. If I stick x into f inverse of x, I get f inverse of x. Then if I take f inverse of x and I plug it into f, out would pop x. Okay, so it's an inverse function. Now, the first thing you want to be able to do is be able to find an inverse function. So it's a four-step process. You can read that four-step process, and let's just go through the examples and show you how to do that. So in our first example, we have f of x equals 1/2 x minus 4. We want to find f inverse. So the first thing we do is, if we don't already have it, we want to replace f of x with y. So we write y equals 1/2 x minus 4. Then we switch the x's and the y. So anywhere I have a y, I make it an x, and anywhere I have an x, I make it a y. So that means we have x equals 1/2 y minus 4. Then we simply solve for y. So it becomes an algebraic equation that we want to solve for y. So first thing I'll do is I'll add 4 to both sides to get x plus 4 equals 1/2 y. Then multiply both sides by 2. So I get y equals 2 times x plus 4. So that then is my inverse function. This new y is my inverse function. So f inverse of x equals 2 times that quantity x plus 4, or 2x plus 8. Now you can always verify by what I just went over, right? If you stick f inverse of x into f, x should pop out. If you stick f of x into f inverse, x should pop out. So it's a nice easy check for you to make sure that you've computed the inverse function correctly. All right, we'll go over one that has a little bit more algebraic consequence towards the end, but it's the same procedure. If I want to find f inverse of x for this function, f of x equals 2x minus 3 divided by x plus 1. First of all, since I have f of x, I'm going to change f of x with y. I'm going to call it y. So y equals 2x minus 3 over x plus 1. Then everywhere I see an x, I make it a y, and everywhere I see a y, I make it an x. So that means I have x equals 2y minus 3 over y plus 1. Now it becomes a little bit harder algebraically because I need to solve for y, because y will end up being my inverse function. So the first thing I'm going to do is multiply both sides by y plus 1. So that gives me x times the quantity y plus 1 equals 2y minus 3. Now at this point, don't get bogged down in details. Think about what you're trying to do. You're trying to solve for y. So you need to get everything with a y in it on one side of the equation, typically the left, and everything without a y in it on the other side of the equation. So to do that, I first must distribute this x through. So I get x times y plus x when I distribute x times y plus 1 equals 2y minus 3. Now get all the y terms on the left. So subtract 2y from both sides to get xy minus 2y over here. Subtract x from both sides to get minus 3 minus x on the right side. Now it's just a pretty simple thing to solve for y, because all I have to do is factor y out of this side here. So I get y times x minus 2 equals minus the quantity of x plus 3. I just wrote it that way just to factor out a -1. It's not necessary, but it's okay. Solving for y, all I have to do is divide both sides by x minus 2. So y equals minus the quantity x plus 3 divided by x minus 2. So f inverse of x is that guy, minus the quantity x plus 3 divided by x minus 2. You can again verify. If you take f inverse of x and plug it into f, out pops x. And likewise, if you took f and plugged it into f inverse, out would pop x. Okay? Now functions, not every function has an inverse function. A function has to be what we call one-to-one. That means every value of y is only generated by one value of x, or in other words, it must pass a horizontal line test. If you pass a horizontal line through the function, everywhere that function exists, it can only cross that function in one place. So this is a little added example for you just to let you know, you should be able to tell graphically whether a function has an inverse or not. So this is a straight line that's not horizontal across. A horizontal line does not have an inverse, but every other line does, because every vertical line you pass through this horizontal line will only cross that, this non-horizontal line will only cross that line once. So that definitely has an inverse. This is an example of an upside down parabola, a minus x squared, if you will. Certainly this will always cross that parabola in two places, so that will not have an inverse. Likewise, this is a type of function that would not have an inverse because I pass it through, and here it passes in three places. This function does have an inverse. This looks like a cubic type function, and any horizontal line passed through this function will only pass it through in one place. So that's how you can quickly tell the horizontal line test. The other thing you should know about the graphs of f and f inverse is that they are reflections of each other about the line y equals x. So in this example, I gave you the function f of x, this guy, and I want you to draw in what f inverse of x would look like. Because it's a reflection about the line y equals x, you just have to draw a mirror image about this line here, y equals x. So any place it crosses, they'll be the same value. So as f of x goes away from that line this way, f inverse will go away that way, and you can just see their mirror images. Since the point 0, 2 is on the function f of x, that means the point 2, 0 would be on the function f inverse of x. Just like when we had to switch the x's and the y's to find the f inverse, it's the same thing. You switch the x's and the y's when you plot f inverse from f. Because of that, the domain and range also switch. In other words, the domain of f of x is the range of f inverse of x, and the range of f of x is the domain of f inverse of x. They switch. So the domain and range of f of x become the range and domain of f inverse of x. So our last example is to look at the square root of x plus 1. This function, the square root of x plus 1, find its inverse, and we're going to plot both, okay? So square root of x plus 1, hopefully from the transformation of functions, you're comfortable that that's just like the square root of x, but because we're adding a 1 inside with the argument, we shift it to the left 1 unit. So here's the square root of x plus 1. So you should be able to quickly see what its inverse would look like, but to find its inverse, so we replace f of x with y, so we have y equals square root of x plus 1. Switch x's and y's, so x equals square root of y plus 1. Solve for y. So to solve for y, we square both sides. X squared equals y plus 1. Subtract 1 from both sides. X squared minus 1 equals y. So that is our f inverse now. F inverse of x is x squared minus 1. So we can see that the domain of f of x is from minus 1 to infinity, because we always need to only take the square root of positive numbers. That makes the range of f inverse be minus 1 to infinity, and you can easily see that from the graph. The range is minus 1 to infinity, and likewise the range of f of x is 0 to infinity, so the domain of f inverse is 0 to infinity.